Plant hydrants are widely used in African countries. When they fill up, a solution would often be to dive the toilet and build a new one. This solution is both expensive and unsustainable due to lack of land. The mobile desludging movement offers a sustainable method for emptying pit latrines and septic tanks that will extend the life of a toilet in a state before sending the mobile desludging to the site. An assessment of the structure of the sludge is to be carried out in order to ensure safety of operations and feasibility. We don't want toilets to collapse or be full of stones and hinder our work.
Nhưng mà cô tức là vẫn là phải ưu tiên cái mặt người nghe, cái mặt người nói.
The first step in the process is fluidizing in pit, turning semi-solid sludge to semi-fluid sludge
Anh đấy chỉ là phụ thôi, em là chính nhé, em là cái người mà lấy chính cái phần diễn giả người ta nói đấy.
Next step is fishing out large rubbish out of the mud drain to prevent the suction from being blocked. This can be repeated twice or more if needed. The last step of the process is the suction of fluidized sludge into a tank. To maintain safe and sanitized latrines is our priority, so we always make sure to clean and disinfect the areas before transporting the sludge to a treatment site.
And presentation today is not just about desludging pit toilets, but desludging difficult sludge. So we define difficult sludge as sludge which has more than 15% total solids. Lots of small rubbish and large rubbish. And for those who are familiar with desludging, there's a difference between small rubbish and large rubbish. And also when the pit is difficult to access. And here there's a picture of somebody standing on a fishing tool on the top of the sludge, just to show you how hard sludge can actually be. So in our trials, we selected 3 types of water. One was the Faecal Mark II Faecal, made in Bangladesh. We also tried a diaphragm sludge pump, which was part of the mix of water and a ROM. And the focus of the presentation today is the ROM. We found the ROM is high pressure, however, we did a lot of modification to it so that it would work with sludge. And we tested it in one type, Malawi, for effectiveness and efficiency. And during 2014, we removed 650 cubic meters of thick sludge, all from paying customers. So we didn't do any free services. And we tested, so 650 cubic meters, that's about over 800 times desludging, because the capacity of that rock is 800 liters. So 650 cubic meters, that's about 300 household pits, and the rest is institutional pits. Now, sometimes it's difficult to know whether the pit is lined or unlined, but our estimate is that 80% of the pits that we emptied are unlined, and we never had any collapse. Okay? The most we got from unlined pits was during the sucking process. We also got sand and gravel into the holding tank, but we never experienced any collapsing pits. And that was always a fear of ours. Yeah. So the specification of the ROM is 800 liter sludge tank. It's got a 200 liter clean water tank. So out of the 200 liters, we generally use 100 to 150 liters for the fluidizing of the sludge, and the rest 100 or 50 liters for the cleaning up process. It's got a Honda engine, and that's very important in Africa because Hondas are repairable everywhere and you get spare parts everywhere. There's also an off-the-shelf vacuum pump and an off-the-shelf high-pressure water pump, which we set to 60 or 100 bar, which is very high pressure. Now, the setting of the pressure depends on the skill and the setting of the operations. If you have very skilled operators, you can set it for 100 bar, and that makes the operation faster and more efficient and use less water. However, if the operator is not very skilled, this can also be quite dangerous, as 100 bar, of course, significant damage. Yeah. And we also insist on 3-inch hose, so that we don't have to fish out too much rubbish. You know, the narrower the hose, the more rubbish you have to fish out from the kids. And we've also tested the unit 30 meters. So we've pumped, most of our pumping is actually at 30 meters distance, and sometimes we've also tested 2 meters, 4 meters elevation. Okay, so the strength of the equipment, though there's always weaknesses and strengths. The rock is made in Netherlands. It's a very good quality, reliable and durable. The design life is, would you believe it, 25 years. That's not for the engine, but for the tank and the frame. It's a 25-year design life. It's an integrated machine. So the Honda engine drives both the vacuum and pressure pump and high pressure water pump. It's compact. It only weighs 350 kilograms, believe it or not, and it will fit on a 2-ton truck, on a flatbed, or it can be modified to be towed as you saw in the picture. It's simple and fast. We manage when the conditions are right and institutional free. We can do 9 trips in 1 day, and we've done this multiple times. It's also simple to repair in the field if there's a blockage. It's quite economical. It uses about 1 liter of petrol to empty 800 liters of sludge. As I mentioned, Honda spares are available. Well, at least they're available in the weaknesses are, at the moment, because it's only made in one factory in Netherlands, the purchase price is quite high and it has to be freighted. So that means it's also not very accessible on the local market. It does require well-trained staff to operate and maintain, but it's not rocket science. A few hours in safety operation, but it takes actually longer to make an assessment of the sludge. It takes longer. So usually operators need at least a month experience to operate the equipment very well. All right. Sorry, next previous slide. Yeah. So there's also a lack of spares for the vacuum side. So while the engine spares are available, a lot of the suction pipes, not the flexible, from the vacuum pump, they do perish, and these are not available on the local market. Thank you. Okay, so I'm going to talk about not the whole process, but about the fluidization, the fishing, the desludging, and the cleanup. Okay, now fluidization, as I said, it's 60 to 100 bars, special nozzles, and most kits, out of the, we've got a database, out of 800 kits, most require 15 to 20% water. This is very important for reducing costs, but also, if you want to make a business, clients don't want to see you put lots of water, because they say, why am I paying you to put water in and take water out? So this has contributed a lot to customer satisfaction, but also to reducing operation costs.
solids in the pit. But once we've desludged, we've tested for total solids, and we found that the sludge that we collect in the tank can be up to 50% total solids. And we've also tested it on pits which have been abandoned for 2 years, 3 years, 4 years, and managed to rehabilitate them. The fluidizing process takes about 10 minutes, but very often you have to repeat it. It's fluidizing 10 minutes. The fishing can take 30 minutes, by which time the sludge, which has turned from semi-solid to semi-fluid, starts going back to semi-solid again. So if you do half an hour fishing, you need to do a very quick fluidization, sometimes twice, sometimes 3 times. Okay? And it's also used for cleaning back. So that's the fluidizing process, and you can see the special nozzle there, 100 bar. Okay? At first people think that we will damage the pit, which is unlined, but the sludge is so thick that the pressure drops very quickly. You know, because you put it in the sludge, you don't put it in the air. And the pressure is also used for cleaning up the sludge afterwards. Okay, next. Yeah. Now talking about fishing. Fishing, unfortunately, is the horrible part of the sludging. And in Africa, in Malawi, there's a lot of rubbish which is put in the pits because there's no solid waste collection. Okay? But there's two types of rubbish. There's trash. You know, people have old shoes or old clothes they put in. But there's also secret stuff that even if there was a solid waste management collection system, that people wouldn't put in. And after emptying 800 toilets, you have a good idea of what people throw in, especially the secret stuff. So women put in menstrual hygiene cloths, okay? In Muslim areas, people put alcohol bottles, okay? A lot of people put in ARV, antiretroviral medicine bottles. They don't want their neighbors to see their own ARV. X-rays, we've seen all sorts of things. So sometimes people say, well, if we do public awareness, people won't throw the rubbish. That's not quite true. There's still the secret stuff thrown in the pit. Okay? There's also stones and rocks, you know, from unlined pits, which you know, during construction they can fall in. And the average amount of trash fished out is for a household pit, it can be 20 liters to 40 liters, depends. Institutional pits, 50, 100 liters. Next, please. So you can see sometimes the sludge is so thick that even a rock that size can be suspended. It won't be in the bottom, that will be suspended somewhere. This is the type of large rubbish which can block the intake of the 3-inch suction pipe, or even block the outlet of the disposal side. Okay? Now, the good thing about vacuum is that unlike direct action pumps or diaphragm pumps with valves, the vacuum pumps are not sensitive to small rubbish. Okay, so this is the type of sludge and the type of rubbish that we get. And then here you see when we tried to discharge, it was blocked. And that's an ARV bottle. It's just the right size of for blocking the disposal site. Can you see that, the yellow bottle? Yeah. So in order to remedy that, we put the inspection cover next. So, like I said, we modified heavily. So instead of opening, removing the discharge pipe, we fabricated. Yeah. So the advantages of the equipment. So we have to look at for the owner-operator. That means from the supply side, we have to look at what advantages are there for the business operator. So the business operator, he can do 8, 9 trips a day. No, that's if the distance to the treatment plant or disposal site isn't very far. Okay? It's clean, it's safe for production. It's economical, doesn't use so much water, and it can be sludged most bits. So, out of 800 calls, we only refused to do one call because we suspected it to collapse. So that was the only bit we refused to do. For the pit owner, it extends the life of pits. There's little inconvenience because there's, apart from the fishing, there's no leakages and no smell. And it's value for money because they see no water going in or little water in, and they see thick sludge going out, and they see the pit level go down. Okay, so that's the equipment. And we work with a local manufacturer. Next slide. Yeah. So they put it on the market with our modifications. So basically, the modifications that I described, increasing the tank size from 800 to 1,000 liters, and putting the inspection hatch and improving the nozzle design. So that's it.
Thanks you all. We've got time for a few questions while Sam gets up. You shout.
I'm not sure I shout if everybody can hear me. Right, hi everybody, I'm Belinda from South Africa. Thank you very much. Thank you for your presentation. Just on a practical note, once you've done your fishing, and you've
So I
got,
can't hear once, yeah.
once you've done your fishing, you've got a combination of trash, secret and stones.
Yeah.
In terms of your ROM mobile desludging unit, what do you do with that waste? Because in the picture of the desludging unit, I don't see where that is being deposited and transportation and treatment.
Yeah. Thanks for that question. Yes. So there's two scenarios. When the disposal or treatment site is very far away, usually it's buried on site. Okay. But when it's in the urban area, it's put in that bucket on the back of the pickup. But to be honest, even the wastewater treatment plant doesn't have that capacity to treat that site, because this still remains a problem. You know, the issue of the trash. Yeah.
Another couple of questions? Yeah. If you haven't got a microphone, shout. Shout. Go across.
Sorry, Thomas Hoffmann from Border. Just from interest point of view, myself, I don't really have any further experience with blending of the solid waste. But have you considered actually blending the waste before it enters your tank? And is that in any way reasonable for you?
So I don't follow what you mean by blending.
Yeah, well, if you have that huge bottle, for example, which is plastic, I think. So that just to get an agglomerate of solid plastics before it enters the tank, and then later on it's easier to handle at the separation, the mechanical separation of the wastewater treatment for the sludge treatment plant. You see, a blender before entering the tank. Was it in any case of a motivation from you to think about maybe for the future development?
Yeah, I'm not sure if I understand about the blender, but we did try to put rough sieves for the intake. Okay. Now the rough sieves for the intake, they would be immediately blocked either by the large rubbish, but even when you fish the large rubbish out, it's within seconds it will be blocked even by the small rubbish. There's a huge amount of rubbish in the pits. I don't know if that answers this.
Would be a better work on that.
Okay,
We can talk about blending and fruit mixes. Okay.
Okay, all right. Like there's a macerator being developed. Yeah. The concern we have about the macerator is then what you do with all these these tiny bits of plastic. You know, we're not sure really what to do with that. Yeah, but also it would add. Then you need 2 machines. Yeah, yeah. But we have been requested to test a macerator. Yeah.
Okay, next question.
My name is Francis Reyes from North Carolina State University in the US. So you mentioned that the price was quite high, the equipment.
The purchase price.
Right. So I guess we were encouraged to ask the scale of question. What is this feasible in terms of scaling up for a business? What would be the payback period if somebody were to invest in that?
Okay. In first year of business, okay, the purchase price is roughly $20,000, but in the first 15 months of business, where the first 6 months the uptake was very low, the revenue was $42,000. Yeah.
I know, I couldn't believe it either. 40,000 is a lot of money. Get into this business in Milan.
Yeah, and the mix of revenue is the private households pay $30, institutions pay $60 per trip. So you can do the sums. And the mix is 30% of the about 40% of the clients are the low-income households, and 60% are institutions.
One last question from Jamie.
Jamie Radford from Northern UK. You talked about comparing the vacuum, the ultrasound diaphragm pump and ROM. Did you do any quantitative testing? Because often the issue with comparing different technologies in one place, the pits are all different, and your pits are going to be different to an Indian pit or a Vietnamese pit. Have you done anything that actually puts a number on what they can pump?
Basically, we couldn't operate either the vacuum tag or the diaphragm pump because the sludge was simply too thick. So we got a separate fluidizer. We got a Karcher, which could also fluidize at 100 bar. The diaphragm pump we had to exclude almost immediately because of the valving. Even if we did fish out all the large rubbish, small pieces of paper would stop the valves from sealing. So we had to eliminate it completely. The vacuum type had several problems. One, we got the self-propelled Mark II. So one is we couldn't license it for road use. Secondly, if we did, it's just too slow. Then we had a lot of quality problems. It was a Chinese engine, it broke down, we couldn't get spare parts. So, but there's nothing design-wise with the vacuum type. If it had high pressure water, that wouldn't make it work, and it wasn't self-propelled. So, unfortunately, in the slide, there's, can you go back? Oh, okay. In the slide, there were 6 features for a design team, which would be important. You know, so we're not promoting the ROM necessarily, but we're saying these are the essential features for a mobile sludging unit. You know, 1,000 liter capacity, 3-inch accessible tank. High pressure washer with nozzles. So any manufacturer, and one of the things that we are looking for is reducing the capital cost by local manufacture. So you don't have to be ordering from.
Thank you. Anybody goes around on a very interesting machine, I suggest you talk to him. He's built it backwards. So if anybody wants to do this, I suggest you contact him. Moving on, I'd just like to introduce you to Sam Wilanger from one of the people in Uganda who's been working on a different form of Goldman-based detection.
Thank you, Steve. My name is Samuel Malinga from Water for People Uganda. going to present about Desludging, low-cost Desludging pump in Uganda. Brief introduction. Water for People Uganda, we try to develop sanitation technologies and water which are affordable for everyone. Provide to different communities, including urban and rural areas. Water for People SuSanA mainly handles sanitation technologies. And we are a group of
Nếu mà đầy thẻ đưa anh có ngay nhé.
engineers, some from
số 3.
We can hear you quite well.
We're a group of engineers, we have engineers headquarters and Ugandan engineers. We try to manage and drive forward the development of affordable, improved sanitation technologies to a point where they can be adopted and owned by the private sector operators. So I'm the lead person in extraction and everything. Currently in Uganda, we have a GALPA 1 and a new GALPA 2, popularly known as RAM. The GALPA 2 has the principle of its operation has the outer casing which slides up and down, forcing slide into the pump without sanction. So when we were developing these technologies, we had to do a slam pond test. We used empirical formula designed by Jan Radford. Why we did it? Because during testing there's a lot of handling. And handling sometimes exposes us to sludge. So we didn't want to get exposed to real shit first. We had to first do a slam pond test, which aided us in preparation of synthetic sludge for pump testing. So according to Japanese formula, we use 50% chlorine clay and 85% topsoil. This one required around 2.2 liters of water. After forming that similar mix, we added water at intervals ranging from 100 milliliters to 200. Then we carried a slam oil fall at respective water added, as seen from the picture. From there, we fed in our data in Excel sheet designed by Jeremy, and we're able to generate a shear strength curve versus water added. From this curve, you can see clearly the lines according to the work done by Steve and Jeremy. Thank you. According to the work done by Steve and Jeremy, they predicted that 100 pascals, 500 pascals, and 2 kilopascals could be appropriate to provide boundaries to test the range over which these pumps can perform or pump sludge. So as you see from the dotted lines, it shows you the percentage of water being added to form a similar mix for specific shear strength. So for 100 pascals, we need around 3.
We can't hear you as well with the microphone. If you can use the podium, we can actually hear you better. Sorry.
Thank you. Thank you. So for 100 pascals, we needed around 3.2% of water, and for 500, we needed around 0.28% of water. From this, we're able to mix 3 barrels of sludge, and we tested our pumps. Next. We mixed 3 barrels, one for 100 pascals, one for 500 pascals, and 2 kilopascals. From this, we tested our pumps. The first pump we tested, as you look at the first picture, we had to lower these barrels down and set up a slab, then a squash factor, emulate a bit like environment, because we designed these technologies putting into the factor that they have to be used in a real pit. It should not be big, it should fit the size of a real pit. So that's why we tested in a real pit, something to be like a real pit. So we tested a gulp at 1 and a gulp at 2. Next slide. So me and my colleague, I was weighing 80 kilograms and my friend was weighing 60. So the factors we considered when testing these pumps, the ease of inserting it to the pit and removing it from the pit. Then from there, we also recorded the time taken for each pump for priming it. And we recorded the mass. The mass was recorded after 30 seconds of pumping, and we were able to estimate the average flow rate. The first 100 pascals, we assumed the specific gravity of 1 and 500 pascals. We assumed the specific gravity of 1.2. So for 100 pascals, for thin sludge, it was not thick. Then for 500, it was thick. A gulp 1 failed and a gulp 2, when the rammer pumped it. Excellent. So when we realized that the gulp 2 worked on the rammer, we invited entrepreneurs or operators for a workshop, whereby we trained them how to use the machine and explained to them the principles of operation. Then after demonstrating to them that it worked, we had a field test. Please play from that video. So that's a typical sludge found in Kampala, most pits of thick sludge, and we feel like the rammer or gulp 2 can handle it. We have worked with several entrepreneurs, and they find the machine is easy to operate. So you can realize that machine can fill 50 liters in 1 minute. But if the sludge is a little bit thin, it can take less than 30 minutes, depending on this priming it. Next slide. So why gulp 2 is superior to a gulp 1? It can pump strong sludge or thick sludge, as seen from the previous video. Also, the hose pipe helps deliver sludge to container in a sanitary manner. From there, there's a device we use for transporting it. It's also clean, it doesn't have any spillage. It's called a grapple, designed by my colleague, both worked with us with engineers from without borders. So we try to extend this This one can go around 2 meters, but there's extension mode. Also, as you see, most entrepreneurs enjoy pumping it. They feel like it's like a borehole. They use less energy for operation. Let's go down the bottom. The challenges we faced in the field, most pits have rubbish, the treacherous materials. I think my previous speaker has mentioned about it. But this valve is called a gas valve. It allows rubbish, the moment it passes through this spacing, that rubbish will flow the container. But it's only suitable for strong sludge. Sludge which is thick, but for water it has a tendency to escape. So there's a butterfly valve. If you pass outside there, I can show it to you. But we feel this is recommended for pits filled with rubbish, and it should be thick. So also, very many times we have designed these machines according to the standard specifications, but when you go outside there in the field, find some pits are really substandard. So we have normally crack some, like on a squat hole, crack it a bit, and when the machine pass through. Also, find the roof is low, so we remove the iron sheets, then put back. So those are the major two challenges. In fact, when I tested this machine in November, we filled 10,000 liters of sludge in 1 hour. It was quite near. So, pump plus fetching, you can see the principle is very good, and this principle has been spearheaded by Steve Sugar and next slide. So I've already mentioned, but in conclusion, we have recommended that 50 by 50 spacing butterfly valve should be formed. It's suitable for all slide, for slide, big slide, as long as there's no rubbish. And 50 by 50 gate valve for strong slide with rubbish. Now we are at the final stages. We are starting marketing and legalizing the use of a GALPA 2, involving the local authorities, such that they approve it. In all pits we empty, we recommend that we try to ask households not to dump rubbish into the pit because it makes the whole process lengthy. And we try to reduce prices if they follow it. But I know it's a challenge, but we always ask them if rubbish was not there, we could see it was actually to take a best time. Thank you.
Okay, questions for Sam?
Yeah, I am Deepak from Practical Bangladesh. So thank you for a nice presentation, but I have a lot of questions. I got it down. Yeah. So my question is to what is the efficiency to collect solid part of the septic water? And along with this, did you do any study who use this number considering the business viability?
Okay, good question.
name is Daniel Nywenda from Malawi. First of all, I would like to commend you for the presentation and also the changes that you made to the GABA. I happen to have used the GABA one and really found challenges in the amount of energy that was used to pump the sludge. But the modification that you made, I'm sure it will be easier. Now my question is on the safety of the people around when you are emptying the pits. In your video, I saw a young boy, even to about less than a meter to the drum that you were putting the sludge in. I just want to find out what measures are taken in Uganda to ensure that people are not put at risk. Thank you very much.
Thank you. Let me first answer those two questions.
Thank you very much. My name is Wells from Malawi. Once again, thanks for your presentation. In your presentation, I saw that as engineers, you've been working with the entrepreneurs in terms of how you're developing technologies. I don't know at what level were you able to involve or to engage the end beneficiaries of the technologies. I'm asking this considering that even in my country, Malawi, we see that people are very reluctant to spend on sanitation. So if we develop a technology for sanitation, how sure are we that it's going to be taken up? I'm thinking of a biblical principle of John the Baptist. John the Baptist was there first to prepare the way. So how best are we able to prepare the way for the acceptance of these technologies in the community?
That's CCAP man, I think. Okay, just want to make sure we've got enough time for all the senators.
Thank you for your question. About the business models, we have two business models. There is pick and pick up. So actually, we have tested several business models of this technology. Ideally, if you are an entrepreneur, you can get roughly $20 per operation. That's if you remove 6 barrels of sludge, 250 liters, you can get that. For the young boy, if you looked at the video, I tried waving, telling him to go back, but because he was excited, and I didn't want to stop the filming. You get it? He came closer. But most people get excited and just come. So, but I tried telling him to go back, but he didn't. I think he saw the video. So, about involving the end users, like we do sanitation promotions, like promotion week. We tell the end users that we can empty like 2 barrels or 3 for free, then the rest you pay. Then when they see the technology working, that's when they get excited and start paying for it. But it's a big challenge. Even most of our entrepreneurs still cannot afford this technology. But the details of the business model, please, if you go to water chat, you can see how we broke it down. Thank you.
There's a lot more to exempting technologies and all issues around business models, which is another big long session. And one of the issues that we have had is the adoption of the rammer. Why would an entrepreneur take on the rammer when they think they've got a perfectly good filter? Occupational health doesn't seem to play much of a part in it. So now, quickly on and introduce you to Jonathan Annis, who's going to give his experiences of working in.
Appreciate it, Steve. Thank you. Good morning, everyone. My name is Jonathan Annis. I work for CARE. I spend most of my time working on a USAID funded project at Washington, D.C. called Watch Plus. And I'll be talking today about some experiences that we've had over the last 2 years or so in trying to professionalize traditional fecal sludge handling practices, but doing so with very low cost, very simple technology in Madagascar. I'd like to recognize my two collaborators on this effort. One is Xavier Grass from the Pacific Foundation, and the other, whose name isn't mentioned here, is Francisca from the organization Crotros out of the Netherlands. So just to give you an idea of current fecal sludge management practices here in Madagascar, about a third of the population lives in urban areas. There are no sewer systems on the entire island. All of the latrines are on-site sanitation and require some sort of fecal sludge management. There's about 10 fecal sludge trucks, but the majority work in the capital. And so because of that, you have a very robust kind of informal network of condemners and people who are doing fecal sludge management, but in a very informal way. The two case studies that I'm going to be focusing on, the first one is in a town called Ambusta, which is here in the Highlands, and then the second is a coastal town called Hanoi. Okay. So here in Ambusta, the USAID and Watch Plus wanted to kind of have the first forte into professionalizing fecal sludge management that we believe has happened on the whole island. So we wanted to kind of start small and start in a place that we already had really strong relationships with the municipality. So this town is a regional capital, 40,000 people. We did kind of a baseline survey to understand what the traditional practices were. Found out that pretty much 100% sanitation coverage. 82% though used dry pit latrines, and the rest were with septic systems. And so what we did together with Practica is we recruited a local entrepreneur who expressed interest in learning with us, and then we designed an entire fecal sludge management chain from the extraction to the transport to the dumping. So I'm not going to talk about the dumping here, but the end use for this sludge was simply to bury it in a site that we got from the commune and was designed specifically for that use. Okay. So in terms of tools and transport, as I said, we were looking at very low-cost technologies, ones that could be manufactured there locally, there in Brewster, or technologies that existed in Tenerife that we could purchase. So in terms of the tools, we looked at Golfer. Our experience was very similar to the previous speaker. Had a lot of problems, particularly with pit latrines. In terms of the septic tanks, we tried two types of diaphragm pumps, and they worked fairly well, especially the diaphragm hand pump. But at the end of the day, for this type of an application, a good old rope and bucket and shovel turned out to be the most efficient way to extract people's sludge. In terms of containment and transport, we designed and manufactured a very simple trailer, which was used for the septic tanks, particularly those that were close to the road. In all of the other cases, we were very similar to what you saw in the previous presentation, using 40 to 60 liter barrels that were very easily manageable. We could get them close to the toilets. They weren't too cumbersome, too heavy once they were full. And importantly, they allowed us to quantify the quantity of sludge that we were getting. So it was a much easier and transparent way to then ask the end user to pay for a certain volume. And we also did some work around optimizing or retrofitting a simple hand cart, which is found on that one. And that was really helpful to take the full barrel back to the main road. So this was kind of just like a pilot learning by doing study. And so what we learned in about 6 months working with this private entrepreneur, we treated 84 cubic worth of sludge. We found out that the transport and the human resources costs were really the driver of cost for this. What we were able to reasonably charge for a tariff was $34 per cubic. And we did some modeling to come up to find about 20 cubic per month would have been the break-even point. Unfortunately, because of the nature of the service provider who we chose at the beginning of the process, they were not all that interested in continuing the service after the pilot. This was a woman who, she was a road builder and she was into building schools, and so the profit margins that we were able to present to her with this service were just not very attractive. However, very shortly after we were done with our work, started working with Protos to replicate and scale some of the thinking that we had done. In the coastal town of Tamatas, this place is very, very different from the previous site. It's on the coast, in a place with heavy rainfall, a place with very low water tables, and a place with very diverse types of filtering. So we did a baseline study and we found, as opposed to the 2 different types that we had at the previous site, we had about 4 different types, all around 20 to 25% of all of the streams there in Tamatas. And the potential volume for this market was considerably higher than what we had seen before. And so when you looked at it, what we found was that there was really a fascinating kind of scenario that it had been playing out there in Tamatas for many, many years. We estimated about between 200 to 300 informal workers who would be called upon to simply transfer the sludge out of people's full latrines and to rebury it somewhere on their same plot of land. We discovered that there was one private operator that had 2 different types of trucks, but that he was only treating a very, very small quantity of the total volume of sludge that was there. So what Patrick and Protos were trying to do was to really professionalize this system and try to get the sludge off of the We also discovered that there was a private treatment plant that was being run by a local mining company, and they agreed to take the sludge that we were able to extract from this part. Next, please. So without going back into the method of extraction, I'd like to focus just on the transport aspects. So how we designed the model at first was to collect all of the sludge and to bring it to a centralized place that would then be transported once per day to the treatment site. And we looked at 3 different technologies for trying to make that happen. Sorry, go back. And first was a pickup truck with a trailer. The second was a type of a very light tractor, which is very common there in Madagascar. And the third was a modification of tricycle. As you can see from these different parameters, the 4x4 truck and the light tractor, they actually perform about the same. But because the cost of the light tractor, both for the capital cost to purchase the equipment and the maintenance cost, is so much less, we went with these 2 options as the 2 that we would take the service forward. This option here was really only for those drum latrines, which are very shallow, between 100 and 200 liters, and they need to be emptied very, very frequently. Due to the nature of the service, we realized very quickly that our thought to have all of these types of transports going to a centralized location wasn't going to work because of the timeliness of the demand that we were getting and the spatial realities of getting calls from different parts of the city. So what we ended up doing, next week. So what we ended up doing is coming back to a service where each day, after there was 3 site visits to assess the type of latrine, the volume, the type of equipment, the number of people that would be needed. Each day they tried to aggregate demand such that they could have multiple teams working at the same time, and then they could use a 3-ton truck at the end of the day to go around and pick up the sludge that was cordoned off at each one of the client's homes. So here in the morning, you would have the team going out to each one of the client's homes. They're working, they're in tandem. They cordon the sludge, wait for the truck to come by, go to the station, clean up their materials, start again the next day. And so what we've seen that in 6 months, this is from June 2014 to November, they treated 221 cubic of sludge. Interestingly enough, it's not so much the total volume of sludge which is treated, though that's certainly an important aspect. I would argue that the volume per day worked is really the critical factor to making this work. And so the current business model, as we're thinking now, requires a team of 6 to be able to treat 4 cubic per day for at least 11 days per month. Anything above that is really very good. The other point that's important here is look at the difference between the number of clients who are from septic tanks and the volume of sludge that you're able to pull out of septic tanks. So for 94 clients that have septic, we were able to get 122 cubic meters, as opposed to the number of clients, 49, who are using the drum well trains and only 9 cubic. What we see is that the business case doesn't really make sense for offering a service to the poorest of the poor who are using these types of machines. Okay. And just 3 really quick takeaways. I think that we found that very simple rustic tools, shovels, buckets, and barrels can be effective in starting up a sludge management program. The next step would be a standardization and simplification of the types of the pits that we're using, so that we didn't need to consider so many types of technologies for each pit that we're emptying. The second point is that, particularly for the case, their automata, equipment, and transport options are available locally. We have an entrepreneur who's going to be taking over the service of their automata. He'll be essentially buying the business plan for about $4,000, and that's going to cover really all of his startup costs. So for relatively low startup costs, you can start this business. However, it's really trying to get the market aggregated and looking at other innovation within the business model that is where you're going to really make your money. So the transport and the tools are only, I would argue, a very small part of really making this work. And then the third piece is what we saw on the previous slide, that in a place like Tamatop, it's the septic tank users who are really the ones who are driving this service right now. And as the speaker from the World Bank said this morning, as we look ahead into the future and look to the Sustainable Development Goals, we're going to be asked to try to find ways that we can get into serving the poorest of the poor. That will probably, in a case like Madagascar, require some sort of a targeted subsidy or some sort of other incentive structure, because at this point it just doesn't make very good business sense. Thank you.
Lots of good points came out there. Questions?
Thank you, Jonathan. So it's David Stoll from Partners Development. Thanks for your interesting presentation. Your 80% or how many that percentage that use smaller streams where the contents are simply buried nearby in the ground. Are you trying to change that practice, and if so, why? Because Wednesday morning I'll give a talk about quite a lot of work we've done on trying to look at the concept that versus the groundwater, which most of the time is not true.
Yeah. That's a great point. So their automaton, the groundwater table is between half meter to a meter and a half deep. So yes, I think that you do have some potential issues with groundwater contamination. Their automata, they use what's called a pump tank, which is just like a pitcher pump. And essentially every house has a pitcher pump. So you're really never more than 3 to 4 meters from more dangerous than the groundwater problem that you've been.
Thank you. Thank you for your presentation. I work on the same project with Sam, and you made a comparison between diaphragm pumps and girl pumps. In Uganda, we tested the diaphragm pump on some of what sludge, and was not doing well compared to the girl pumps. So I believe to make a comparison based on the native thickness of the sludge.
So for us, the diaphragm pump was really only septic. The septic systems, it didn't work any better. Perhaps it was even worse for the pit latrines. And fairly similar to the first speaker, we did try some ways that we could liquefy the contents of the pit latrines, but at the end of the day, because of all of the solid material and just the sheer mass that's in there, it's really, really difficult.
One last question?
One more, and then we're going to hand it over.
I'm Vinay Shah from Nepal. Just looking at the figures, the financial figures, and looked a bit high. And I thought, is all the financing done through private sources, so private banking? So you're also looking into the possibility of collaborative financing to the city and the private sector, or the thing called viability gap financing, where you try to make it viable with additional funds coming in from the government or the city to make things more affordable for the poor.
Right. So I think that we've identified that affordability for the poor is still one of the issues for this model, which is outstanding. I think what we were trying to do is just come up with a very rapid, on one hand, and a very, very low-tech, very simple solution on the other. That could be easily viable for someone to take it forward without the project. So how the model is now is there's no external financing. They're trying to run all on the cost that they're collecting from their clients. And because the pricing is set the way that it is, we're essentially pricing the poorest of the poor out of the market. And we recognize that. So that's something that we can take forward.
Thank you.
Good morning, everyone. My name is Sebastian Tillmans. I am here representing Resource. And I have two objectives for today in presenting this research. The first is to introduce and define container-based sanitation as an alternative to fecal sludge management, in particular in areas where there are no roads and it's hard to bring a truck to empty the waste or a vehicle. And the second is to introduce the idea of using a mass balance approach to assessing the effectiveness of a service. So we heard from earlier speakers today about how there's a strong correlation between density, urban density of population, and fecal exposure. So really our objective in fecal sludge management is to reduce fecal exposure, reduce the sheer mass of material existing in an urban environment, fecal material in an urban environment, remove that so it doesn't, so people are not exposed to it. So to quickly go over some of the challenges of non-sewer, non-network sanitation today. One is, in dense urban sludge, we often have a very limited amount of space, so we tend to promote public toilets as a sanitation solution. The problem with those, of course, is that there's a lot of administrative problems, tragedy of commons, they're broken down, or they're closed at night, which limits, of course, the amount of feces that you can capture in these toilets. And then with pit latrines, as my predecessors have so thoroughly demonstrated, it's extremely challenging to empty those pits and actually remove that waste in a hygienic and effective way. There's another actually nuanced challenge with private pit latrines, is that in dense urban slums, in areas where the residents are dominantly renters or squatters, there's a lot of turnover, so people have to move frequently, and it's very hard to get them to invest in a fixed asset like a pit latrine that's either going to raise the land value, the property value of their landlord, or and they're going to have to leave it behind if they get evicted or they have to move on. So what's an alternative? Well, container-based sanitation. And then you've got, of course, the alternatives that we know are flying toilets where people use a plastic bag and throw that plastic bag to as far as they can, and open defecation, neither of which are effective mechanisms for fecal management. So what is an alternative? Container-based sanitation is a sanitation concept that's designed for full cycle management. Essentially, the waste can be captured in a sealable container right from the get-go. So the toilet is built around a sealable container, which can then be swapped in and out by hand carts, brought to the outskirts of the community where there is road access, put on a vehicle, and brought to a facility, in this case I'm imagining a compost facility, for reuse and trying to obtain some value added from the back end. We implemented one of these services in Cap-Haïtien in Haiti. Cap-Haïtien is the second largest city in Haiti, and we deployed a service there in close partnership with an organization called Soil, which I'll note right away continues to expand this service and to improve upon it and to make it better every day. So they've been a very phenomenal partner. To give you a sense of the community where we worked in a community called Shadow, which is an informal or illegal settlement within Cap-Haïtien. It's got no roads, no water supply, no sewer service, and it's essentially at sea level, which means that even if there were pit latrines, the pit latrines that are there become these very effective shit-spreading devices every single time there's a flood, which happens very often in this community. And there are also 3 public toilets there operated by Soil. Those public toilets are actually operated as container-based toilets. Specifically, these public toilets that we call the sort of premium public toilets, they're free to use, so there's no barrier to using them in a financial sense. They're open long hours, from early in the morning to late at night, and they have a paid attendant that's making sure they're both safe to use and clean. What we deployed is a household container-based, these are, I should specify, are urine diverting toilets. The feces and the urine are captured in containers that are underneath the slab, and those are swapped out as soon as they're full and brought to the compost facility. We deployed a household level service, which was also built around urine diverting toilets. So the feces are captured in a 5-gallon, 20-liter container, and urine is captured in another separate container. The users cover their feces with dry cover material called bonzo d'air, that's Haitian Creole for good smells. And it's a mixture of crushed peanut shells and dry sugarcane bagasse. Twice a week, we have a collection service that comes and swaps out those full containers of waste for clean ones. Those containers are brought out to the outskirts of the community, where they're put on a truck and brought to Soil's compost facility, where they're composted thermophilically to reach temperatures above 60 degrees Celsius and kill off all the pathogens. So that they're then able to use that waste, that compost could then be sold as a value-added fertilizer. So now, digging into how we evaluated this service. How effective was this service at capturing and managing waste in this community? We can break that question down into more detailed questions. The first is, how much waste is actually being produced, and where and when is it being produced in this community? To answer that question, we deployed a baseline and endline survey. So we interviewed 150 households, a little bit less than 150 households, before the deployment of the service and after the deployment of the service. And we also interviewed a control cohort of households in the same community that were not going to receive the service, but also on a before and after. We also conducted public toilet observations where someone actually counted the number of users using these public toilets and weighed the feces containers at the beginning of the day, at the end of the day, and whenever they were swapped out. The next question we had to answer is, how much of this waste are we capturing? To do that, we tracked the operations of Soil service, and I'll get into a little bit more detail of that. I found we were interested to see how much it cost, even though this was a pilot and the costs are probably not representative of what was going on at scale. So that we tracked Soil's operating expenses during this service. To give some detail, and this is where we start talking about a mass balance approach on how we were tracking the service. You can think of the compost facilities, the receiving facilities. We've got containers with cover material getting delivered to the public toilets and the household toilets. And then we've got containers full of feces and cover material returning to the compost site. So in engineering speak, if we draw a control volume around our compost facility, we can actually measure the amount of material coming in, subtract that from the amount of material going out, and we end up having a mass of feces that we're capturing, right? So here's my equation for the engineers in the room. So that's basically saying that mass of material in minus mass of material out is the mass that we're processing. So in the public toilets, we observed these public toilets for a total of 15 days and found that the public toilets have about 1,300 users per day. And we're actually, because we could count the number of users per day and the amount of waste that we captured in every given day, we got a very refined sense of what is the weight of a single defecation in this community. It's 163 grams, with actually very tight error bars. Taking that number now, we can also look at where and when is the waste produced, our data from the household survey. So what we find here is that by day, about half of residents are reporting using these public toilets. And these are, remember, these are great public toilets. They're free to use, they're clean, they're safe, they're conveniently located, they're open long hours, right? And we're only getting 50% use. And then, at night, that number drops down to 29%. And the difference is actually made up in these dark red categories, which are flying toilets and open defecation. So people who can't use the public toilets at night are defecating in bags or defecating in the open, which is the exact opposite of what we want to happen. Now, after our service, what we found is that we have very, very high rates, 80%, more than 80% by day and by night, using the household container-based sanitation service. And the other exciting part about that is that you see there's we dropped the reported use of flying toilets and open defecation to almost nothing. Now let's collapse all of that into an actual mass, in terms of mass. What is the share of mass that this service is capturing in this community? So at baseline, in this community, container-based sanitation through the public toilets was managing 46% of the feces generated in this community. So that means that more than half was ending up still in the community. At follow-up, we moved that number up to 85%. So we're actually reducing the amount of unmanaged feces in this community by a factor of 3.6 through this service. Almost all of that gain was through deployment of this household container-based sanitation service. And I'd be happy to talk to you about the reasons why I think that is. And if we look at the share of feces that are unmanaged, how they break down, a portion of that is pit latrines. And the problem with pit latrines in this community is that when it floods, that waste is spread around the community. And the few pits that are emptied manually, there's no place for that waste to go, so it just gets dumped into the nearest canal or ditch. So it's not getting managed appropriately. But what we're seeing here is, again, we're dropping the mass of waste that's going to flying toilets and open defecation to almost nothing. That, I would say, is your most hazardous shit. And this service managed to almost eliminate it. So this service was a pilot. It was we initially deployed it to 150. We offered the service, and we initially built 150 toilets. 135 households actively used the service. We collected 650 kilograms per week from them of feces, so that's already taken out the cover material. And at a pilot cost, we did this at about 96 cents per kilogram of shit. And the public toilets were a little bit cheaper, but like we saw, were also less effective at capturing waste. So these numbers are, I look at these numbers as a way of saying, okay, we're anchoring ourselves, and how do we compare it to our literature-reported values of sewer service? And literature-reported values of sewer service are lower in terms of a cost per kilogram of managed waste. So this is a sort of first glance, this is of course really disappointing, but we have to remember that this is a very, very small pilot, and it's also, the data is from the service that we did in 2012, 2013. So our partners of soil have drastically reduced the cost of these numbers as they refine their operation. But I think the important point to see here is that a large fraction of these costs are actually fixed costs. which means that as the operation scales up from 135 households to the kind of scale that sewerage enjoys, you would see the numbers drop considerably. So those are the main findings. What we've had here is an extremely effective system for capturing the waste and managing the waste. We've got some very, very happy customers. Some great partners. So this work was funded through a Grand Challenges Explorations grant from the Bill and Melinda Gates Foundation. I want to give another thank you to our partner Soil in Haiti and some other sponsors. And I'd love to take some of your questions.
Thank you, Sebastian. Some really compelling arguments there. Questions?
Thank you for that next presentation. What is known after 2013? What is happening after the Faecal? And then you say the changes were free.
So I specified, so the public toilets are free to use and they continue to be so. The household service, we deployed it actually as a 3-month free trial, where, so for the 3 months that we observed the service, it was free for households to use. Afterward, it converted to a monthly subscription service. So every household had to pay a monthly fee to continue to use the service. And what we found there, I'm scanning the room to see Sasha Kramer, the executive director. There she is at the back of the room. What we found is that there were very, very high payment rates. So at the end of the 3 months, users in this pilot had the option of renewing their service, continuing their service, and paying for it, or returning the toilet and no longer participating in the service. And I think the numbers were above 80% payment rates for the service. And so what's happened since then, again, Soil is the members of Soil are the best people to talk to. The service has continued to expand as a paid service with very high rates of payment from households.
Can you say how much they're paying?
In Cap-Nation, the original fee was $5 a month per household. $5 US, so the equivalent of $5 US.
Hi, my name is Sandra. I'm from South Africa, and I just wanted to know if you had any idea before you started that about the social and cultural acceptance of that. Was it already clear that a system like this would potentially work, or did you do a lot of convincing and said, wow, this is awesome, and you had like wonderful stakeholder involvement and something like that? That's the first thing. Then a little bit that goes into that is any problems with flies or odors or anything like that, and waste in the feces. Do you have any problems with that, like any hygiene problems?
So I think I'm actually very glad you asked that question because it gives me the opportunity to shamelessly plug a presentation that's going to be happening tomorrow by my colleague Corey Russell, who is going to talk specifically about that, about user acceptance and the results where we interviewed people's perceptions of their sanitation solution. And I'm not going to scoop his results, but I'll say that there was very, very high acceptance rates. As part of the development process for this service, before we ever deployed any toilets and deployed the service, we actually spent a year in Haiti working very closely, pursuing a user-centric design approach to understand what makes a toilet and a toilet service something desirable and exciting in this particular community and this particular cultural context. And so there's a reason that this toilet is all white, that it has this white toilet seat on it. And that's basically based on our research that we conducted in the community, where we found that in Haiti, a flush toilet, a white flush toilet, is called confort moderne, which means modern comfort. And so if we think of what motivates people to invest in sanitation, especially in their home, it's not protecting themselves from diarrhea. It's usually having a clean toilet to use, having something that's going to make them feel safe, private, and actually, stylish. That's something that it's kind of a symbol of status. And in Haiti, at least, the imagery of the white flush toilet conveys those parameters. So that's why we designed that toilet as that way visually. Now, we also spent a good portion of that year testing just to make sure that it didn't have flies, that it didn't have odors. And it performs quite well. Of course, one thing that's very important is the supply of cover material and proper user usage of the cover material. But we find that users are actually very motivated to keep flies and odors out of their house, so they tend to use the cover material well.
One last question for this, and then I'll invite the rest of the panel to come up for any general questions that you want to answer. And I have to remind you about 3 main points. If thinking about those, I've got 3 main points, but you don't need to bias the decision.
Just had a small question about the slide number 14. It's between the difference, I'm wondering, do you have the period of time between?
Well, between baseline and night? Or between night and day?
No, the period of time between the baseline survey and the night survey.
Sure, yes. That's so this is 3 months. So before this started service, we conducted the initial survey in September and October of 2012, and we came back for a follow-up survey in February of 2013.
Okay, stand up, presenters. Joe. Sam. Well, okay, it's starting, mate. We're not taking much longer. What's basically about that is you've got 3 public latrines in the daytime, and you're not getting 51% usage. And you're still getting high levels of open defecation and flying toilets. I mean, that, to me, is anybody who sees public latrines as a solution for our community should probably do some of that type of research. So I think you'll find that from now on, we've had 4 great presentations, and everything after this will be downhill. I'm sorry about that. But I do invite general questions for the audience.
Okay. Especially regarding the desludging, when you think about the way forward, is that, do you say pit latrines, we should keep on doing that? Or do you rather see that the desludging technology is something that at the end has to phase out with the pit latrines in general? Do you think that there's a future, or is it more something that you say it has to be in place now, but we should move away from that?
So is there a future in these countries?
I know it's a bit,
you
know, you predict your own death, basically.
We like that. That's on top.
I would hope it's just a temporary solution. Yeah. Yeah. I think it's just the needs that we have to meet. But I think we should move away from that.
I'll speak from the perspective of container-based sanitation. I mean, one of the big motivations that we have for container-based sanitation is the waste is already in the container. You don't have to worry about that difficult transition step. I think that as we think about very long term, well, can we have universal sewerage? Because that would be the only alternative to having pit latrines. And I think that requires universal water supply. When we have, if we were to have universal storage, the question is there enough water for that? And is that the most appropriate economical solution? And I think that in sanitation planning, we should think of the city in terms of a menu of sanitation options. What makes the most sense in a different scenario, in a different context? So there's areas where pit latrines may make sense and can be done very hygienically long term. And there's areas where container-based sanitation may make the most sense. And maybe we want to start managing our feces with organic solid waste. That's a different kind of waste. It's something that was actually started talking about in planning sessions. So I think that we although sewers are certainly a great solution that works well, they're not necessarily the only solution.
think desludging can still remain. Depends from your country, from the level you are in, because it's hard to do without it. And I think it should feel like they should have a specific depth of the pit, like maybe this standard perimeter deep. And the standards should be made for these pumps, and also when it is empty, I think the users should stop dumping in that area. So it will be easy to use, like these pumps and this thing. I think it has to continue for some time.
Yeah, so it's a real marriage between the type of the sanitation facility which is being used and the type of tools, right? So, you know, in the case of Madagascar, it would be great to eventually think that we can move to a more hygienic, perhaps, type of desludging. But I agree that, you know, in the next 20 years, in the next 30 years, I see desludging as still being a reality. If we look at some of the ship flow diagrams that the woman from the World Bank was presenting this morning, there are lots of cities with over 80% of their fecal sludge isn't being managed, and it's not going to take a quantum leap to sewer systems anytime soon, I don't think. So how can we desludge in a way that is more hygienic, but yet still affordable, so that all parts of the population can have their toilets clean?
Unfortunately, the problem from pollution, from the population point of view as well, small towns are getting bigger, cities are getting bigger. It's hard to actually see us keeping up, never mind getting through. Quick one.
Thank you very much. Once again, my name is Wells. I was just wondering, looking at the presentations, we've seen that in terms of desludging, we've been developing technologies, but all these technologies are at small scale, and they have their own problems or challenges. I was just wondering, in your view, if you think it's possible with this globalization, just to think about maybe just one entity or institution that should be responsible for desludging with big funds or machines, while we should be responsible for characterization, which obviously will better inform the utilization of the sludge that we're going to be desludging.
Are you saying that is it one? Are you saying that we should be pulling out and leaving it to one specific entity within a city to do all the desludging? Private sector?
Yeah.
Okay. I think I'll try and answer that one by myself. The market's not working. Okay. There is this theory that the private sector will fill the void and will seek out economic solutions wherever they're possible. Those economic solutions are there, and the void is not being filled. Without some sort of facilitation of the market, either through technology development, through enabling environment, through working with the cities, that void is not going to be filled in the Zuzu or in Blantyre, in Dar es Salaam or anywhere. So I think it's more the role, becoming more of the role of the NGO in that, is this sort of market facilitation, which all of the organizations here do.
And I think built into your question, there is one single entity that does need to be involved in all steps of the process, I think, for sanitation, which is the government, be that the municipal government or at the ministerial level. But I think my bias would be to say, if we can solve the market failures then the market will figure out whether it makes the most sense to have one supplier of services or many suppliers of services. But regardless of that, the government needs to be regulating, permitting, inspecting, and supervising all service providers.
I'm conscious of the time, I know we started a bit later. I'm quite happy to stay, but I would like, we're supposed to find 3 key points, 3 issues that you think has really come out of this presentation. Have you any suggestions from anybody, something that's really sticking in your minds that you think that you really need to capture and push as a conference learner? Yeah.
Hi, my name is Sasha Kramer from Soil, and I think one of the things that I certainly learned from partnering with Sebastian and Resource was that public toilets do not deal with the open defecation problem at nighttime.
For me, it was a very interesting question. Anybody else? No. You have to move a bit faster. Keep awake.
Alison Parker from Cranfield University. I think it's another bit of a negative point following from Sasha's, I'm afraid. But we heard a lot about solid waste, and I was particularly struck by this concept of secret solid waste, the antiretroviral drugs, the condoms, the alcohol bottles, and we say, oh, we can deal with the solid waste problem with education, but I think I was really struck by how it's not just, that there's going to be more to it than that.
Yeah, I would come. We've had problems with the Gulf not working in Madagascar because there's too much solid waste down there. We've had solid waste issues with Joe. This is something that's going out. I spent an hour and a half in a latrine fishing in Malawi. It was a filthy, awful job. The extraction of the sludge after that was relatively clean. And I think somehow when we talk about operator health, we tend to be concentrating on the quality of the extraction and how to pump it, when actually we're not really tackling the fishing problem at all. And those are the sorts of ratios that we were getting. 25% of the waste that was taken out was solid, was rags, cloths, condoms, you name it. It was on there. So that was something that came out genuinely.
Time and time again, I keep hearing how the simple issues, the simple solutions seem to work the best. Whether it was you were talking about your trailers, like you have these more expensive options, the cheaper pipe, the trike worked just as well. Or I was amazed to find that the rope and pulley system and just as fast extracting as some of these high mechanical ones. And then even if you could just keep the sludge in a bucket, it seemed to work out better. So something to keep in mind that simple solutions tend to work quite well.
Để kia kìa.
All our based around Desludging, but trash handling was the biggest issue and our biggest takeaway is trash is the problem everywhere. The second would be cleanliness around the pit and safety of the user. No matter what equipment you use, you're still, I've never seen one operation where you're not getting shit around the pit. So keeping the user safe is a big takeaway for me, and having a service that people want to pay for and that entrepreneurs want to do. So making the market better for them.
Thank you. One point that came out in a couple of sentences, sorry as well. A lot about the viability of these businesses, they are operating on the margins, and we're doing what's very good margins. But capital cost of entry is a barrier, but there is a point that we're missing is about the aggregation of demand. And what the soil system is all about is that aggregation of demand. And I think the next part of the process that we now have to do is how can we reach those sorts of cubic meters? How can we help doctors reach those sorts of meter cube and levels of extraction to keep them profitable, keep them interested. I think that's the next step that we need to be looking at, or one of the next steps.
I'm Dave Dattavatta from Nepal Practical Action. Generally, we are studying in the micro level. We see willingness to pay, and similarly, we should also go able to pay or not. Just in the micro stage, what is the during the study phase or during the community level study phase, what is the economic status of the community? So that let us say $500 is coming. Whether what is the status of community? We can see this. Then after implementation of this study, whether it is feasible for the community or not. It is, I think, essential. Thank you.
Okay. Certainly, that willingness to pay, none of the people actually reported that people were willing to pay. We have some mention of pro bono and how the subsidies work to get to the well. We didn't hear anybody say households would be part of the businesses were viable. So I do question that, whether this willingness to pay is absolutely
what comes out is not willingness to pay, but it's value for money. That's what people are coming out, value for money.
Mr. Sauer, PSI.
John Sauer from PSI. Hello, everyone. I think what my main takeaway was is that we are, and we got to it with the container-based systems, is we need more technology development on getting entirely. I mean, that to me seems to be a big challenge, and I'm just not seeing more sophisticated technology development that's really looking at how do we remove the pit emptying, the collection bit totally out of the equation. So I'd like to see more of that.
I'm Shafiqul from Bangladesh. What I learned from the session that yeah, we have learned about several options and technology is being developed, but it's always remaining questions when we go for advanced scale. Say, if you talk about the container-based technology, say in Bangladesh, Dhaka city, there are 4 billion samplers in the same city. So how do you handle all these billions of technology? It's a difficult thing. This is one. I mean, technology development is one side, but how the company can really use the behavior. And the second thing is technology development is one side, but the motivational aspects is huge. Because in the ROI presentation, all these macros going to the septic tanks become very difficult, issues become very challenging, and also during the Ogata presentation, and also so just telling those things will not work. Because I'm working in a huge hygiene program. We have just last 5 years we are telling the people to watch their hands. So telling people it's very difficult. Very difficult.
Okay. Yeah, certainly the pit is used as a gouge. So the solution to develop a solid waste management. Take 2 more points.
Yeah, I am Peter Chibeta from SuSanA University. My biggest takeaway is the concept of continuous learning, especially with the changes to the first GABA and the second GABA. It just shows about taking the technology better and getting that feedback from the users, such as entrepreneurs, and also the other beneficiaries as the customers. So that is what is needed to improve people's lifestyle. Thank you.
Thank you. And one last point, it must go to order.
Okay, thank you. I'm not going to make a summary or something, but I would like to discussion, if we're talking about technical solutions, that we also like to tend to say it needs to be very cheap, very simple, and needs to be able to treat all kinds of waste, and needs to be the magic machine. And that's not really possible, unfortunately. So I'm looking at, this, for example, the Galpa. From our experience, yes, it is possible to utilize that machine in terms of we don't have solid waste inside the pit, because also fishing is a very statistical work. I cannot watch or look inside the pit, so and later on if my gulper gets clogged, I'll be working and with the gulper it's a mess. So it's really also a regional question. Which area, which country, which culture has what kind of tool can be utilized. So we'd like to look at more systems that can deal with different kinds of waste and that are going into the direction of the waste verification.
Yes, and I know JJ will be pushing this, but some of the sludge testing actually getting more scientific about exactly what these pumps are capable of pumping. Let's get away from thick watery sludge and chocolatey sludge and very subjective descriptions like this. If we're out there designing pumps, let's get a very clear understanding of what we're pumping and how far we're pumping. We're still not there. Okay, thank you very much. I don't know what I'm going to do about the three most important ones. Probably fishing. Investment fishing. Anything else? Somebody has said that this is a bit of a pipe we need to push across. In that case, I'll be fishing, aggregation of demand, and pumping the trees. I think that makes it really quite an interesting thing. Okay, thank you very much. Enjoy your lunch, and I'm sorry it's all downhill from here.
From the holding chamber and transported into a gasifier. And here I should mention our other partner on the gasifier side, which is RTI. So it really is a collaborative effort. So that's a very brief summary of the technologies in the toilets. Do come and talk to me afterwards, and I can answer your questions or put you in touch with a member of our team that can. Just to clarify where we are in our project, so we had our first phase ran until March last year, where we proved the concept of the toilet. The second phase, which we're in now, is prototype development. So we're developing a prototype which we hope to test in the field from February 2016. And if you want more details about the project, then do contact me, find my poster outside, grab me, I'll be here all week. Or follow our blog at that website, contact us on Twitter. We'll quite regularly put updates on our blog so you can see what's going on.
Just to inform everyone, this is a live session. People try to push in as much information as possible within the sessions, but we only have 3 days. I want you guys to take time to actually go and visit the project users for this live session. I think SuSanA is presented earlier. For those of you listed, you can present the management model for urban sanitation. Please have a look at this poster. Shows you which influence is the greatest when doing this type of management. Alison has just presented on the RTGC project, the nano membrane toilet. I invite you guys to actually go visit them. Have a look at the posters. I think Maria from the South, she's around, okay? And that's our next speaker, and she's going to speak on green library.
Hello. So, as he presented, I'm Maria from Brazil. And I'm just going to point here some main aspects of our project. We've been working with UDD toilets in Brazil, but I mean, our research is in Brazil in partnership with the Swedish University of Agricultural Sciences. So we have done some laboratory studies, and what we have find out is that actually the accumulation of feces inside the container of the urine dry and divergent toilets, it happens kind of like what shows in this figure here. What happens inside the containers are like these layers of feces and the covering material that we add after we defecate. So we have this type of fecal sandwich that we see here. And the main problem that we have with UDD feces from UDD toilets today is that we are not sure about the hygienization of the feces. So what we are trying to do is to find out some alternative materials to add after we defecate to cover feces, and that these materials can treat feces other than just avoiding odors or insects. So what we have done is that we've tested a mixture of ash, limestone, and urea. We've tested in lab scale, in a little bit bigger scale, like setting up the containers inside the laboratory, and now we are testing it in real scale. And what we have seen is that the mixture of this material, ash, limestone, and urea, we are having actually like really good results with it, looking for the inactivation of pathogens. So what we have found, like in real scale, is that using that material to cover feces, we could have 3-log reduction of bacteria and viruses, what would give us like 45 days of treatment. So after the container is closed, if you keep that for 45 days, we will have a safe material that can be reused. And this is just a picture of our toilet, the one that we are evaluating in real scale in Brazil. So for more details, you can contact me outside by the poster section. Thank you.
Our next speaker is from Ido.
Very good afternoon to all of you. Myself is Desludging. We are working on the BRDU biotoilet. It is one of the products which we can, this is a completely different story altogether. It is not fecal sludge management, but it is a futuristic aspect of telling how we can, futuristic system management, you can say. It is not only FSM3, it is identified well. Next, please. The problem with the development of these kind of toilet systems is that we can talk about fecal sludge development, generation, then transportation and involvement of manpower, everything is there. Couple of things are there. But in our laboratory we have developed, we thought Basically, if we can reduce the sludge generation, if we can zero in the sludge generation, is it possible? People will say, most of the thought process will say no. But it is possible. It is possible why? As because if we can think about our gut, gut is having almost 10 times more bacteria than our total body cells. And these bacteria are capable of almost digesting many things. Some of the materials we use to ingest, it is not possible to digest, but if we can augment those bacteria into our developed bacterial systems, then it may be possible to zero down the sludge generations. And second point is that in getting flash water, especially in India and many parts of these areas, we used to flush toilets, and that water, potable water, we utilizing for the wastewater. But if you can utilize that wastewater for again flushing, etc., or gardening, at least you can save the water. So is it possible? Next part is that low maintenance. Sludge generation, if sludge generation is very low or negligible, then you are not involving manpower, technicality, cost, especially in developing countries, this is a very problematic thing. Lot of hygiene related problem if we can take away sludge from one place to another. If input of energy is there, then it is another problem to maintain that energy level for drying, sludge, etc. If we can get some energy out of that, suppose methane is a kind of moderating energy, if you can utilize it for some other purposes, then it should be very much eco-friendly and cost-effective. It should be for all. So basically, components of our system is one very specially designed reaction resist, which is already presented, and this group of bacteria we develop. I can come to the bacteria later on. Actually, this is totally anaerobic system. We have tried to create a specially designed tank, smaller tank, but completely anaerobic, where a group of anaerobic bacteria works upon the total states, the hydrolytic, acidogenic, and mutagenic states are there, and bacteria involution matrices are there. And from the water which is coming out of the tank, it may be again cleaned or washed from the reed-based system for secondary cleaning, and that again for tertiary cleaning you can have a UV-based system if you really require it. And second, third, and last part is that you can harvest biogas if it is common level toilet, as because advantages are wide application. It is easily adaptable for customers with single or multi-stage system, as well as there is the concept of tank preparation or tank volume and recycling effluent water systems. And pathogen reduction 99%. Why? I am coming to that. And biogas generation. And so the study part includes many things. And that is bio-augmentation, as I told, of microbial consortium from isolation, spreading, etc. And suppose you have cellulose degrees bacteria. If that bacteria can digest cellulose in some insect gut, why not that bacteria can be utilized and harvest and multiply in a system where only we need the hybrid processes. Next, process enhancement to working the system. We did all this thing along with the metagenomic analysis for the total bacterial inoculum thing. And second part regarding the pathogen inactivation, pathogen reduction. That is an interesting part. We get a reed bed. It is basically not only part of the process of cleaning the water, but also it is covering many things. Number one, reed bed is comprising of bed of pebbles, sand, and reed plants. So plant activity is another very important thing which can kill different kind of bacterial population, and the bacteriophage, which is already present in our gut. And it is 100 times more than our total body cells of our body. Bacteriophage is a specific kind of bacteria that is permanently present in the reed bed. So we utilize that concept as well. So modification of reed beds, how it can be possible, even that septic tank systems or that our biotank systems can be in front of the house. You can landscape accessible reed bed. And the utilization of methane is there, application of such a low temperature, we are working on that part, and implementation of the technology interaction with the people. So this is a very small thing, I cannot go into the detail of that, but all the maintenance analysis have shown the quality control of our the bacterial consortia study is there. So we find a lot of different bacteria along with of hydrolytic and acidemic bacteria, acidic bacteria. Desludging is the end users of all these things. So if methane is being generated, then starting production will be very less in that sense. And basically, methanes are totally end users. So hydrolytic part is the most important, and acidic part is most important in that system. So you have a diversity quite group of methanogens to produce methane in different conditions. So we are basically concentrating on all the 4 states in our bacterial consortium. And this is the general diversity of our bacterial phages over there. We studied it through metagenetic analysis and in the plate study and our transmission microscope, etc. We did all these things. And another part, we also thought, yes, the study which is coming out, human fecal matter which is within our body system, it is containing not only of bacteria but also several kinds of different human enzymes. Being a biologist, I also tried to target out whether that part is present in that our biochem system. That's because those enzymes are basically reacting on that tank as well. So we find out that total functional prediction rates of universal protein, it is purely almost common all these pathways in our system. We have LC-MS studies and everything for analyzing the processes which is going over there. So we get very good quality of water after that. This is the water quality parameters. And implementation is usually going on throughout India. Couple of more than 70 technology partners are there. So we are not basically concentrating on the upper part of the structure, as because this is user oriented. If people have money, then we can spend many more things for the top structures. But we are basically talking about the structures which is underground. And a couple of community toilets are there. Very big flat sizes toilets are there. And here in our laboratory, in agricultural laboratory, we are utilizing that water. This is the top part of the tank, this is bed only, this is the lead bed, and we are utilizing that water for flushing in it. Some visitors were there from our top leaders. And here you have also very important aspect of Indian Railway, where these kind of same technology, that lead beds are not there, but little different kind of tanks are there for Indian Railways, not to have a study the practice. So we have a ecocentric and SuSanA techocentric system made. So these are some of the reaching people is very important for being in the government system. We do have a couple of government partners. We do have presented again at the event at Delhi last year, and I also thank here as well for the Gates Foundation who has given me the funding for coming over here. And why implementation are there? We are also thinking about, as because India, we all know it is almost 60% of total open indicators of the world is in India. Why it is so? We reached out to the people, especially the school level of very small kids. We did small presentation, small painting competitions over there. And they have, this is class 2, and this is my child's painting. So it is like that. So people are, we interacted with everybody. Everybody wants to think, number one, that there must be some water in the toilet system. If there is no water in the toilet system, especially the kid of class 6, 7, 8, 9, there must be toilet, but if you cannot flush after use, then there is no issue in that. And it is very important that there must be some water available in the system. So our system can provide that reuse of that water, wastewater for flushing and use. And we also did some conferences very recently. And this is my presentation. Thank you so much.
lot of detail in the toilet. I think if you're really interested, you need to speak to us. There's a poster. We've done 2 presentations within half an hour or 1 hour, basically. Okay. We have Mr. Sumaya presented on the anaerobic system. Please, if you need more details, we want to ask some questions. And Maria presented on the toilets. Does anyone have some quick questions before we start? I'll take 2 before we move to the next session on the 4 presentations we had. Anyone? Does anyone remember what is the most important factor identified in the management of urban sanitation in Indonesia? One here from me. You can answer that. Okay. Here to the stage. Name?
From the University of Canada. One of the points that we mentioned that the treatment method in the diagram that you showed was categorized under unimportant. And I was quite puzzled by that. So you can explain it. So this was directed to the first presenter from Indonesia.
Would you like to
In the very last line that you showed, that there were important factors, unimportant factors, and technology there was under unimportant factor, and I was quite compromised. So you could explain what you mean.
Okay, this is the perception of community in slum area, right? Community in Indonesia, the technology is not important. The point is sludge can be treated, and impact on environment is good. That's the point community perception. And the important thing, community perception is force and community common. I think that's
okay. Anyone? Question?
Don't worry, my voice is loud enough. From Professor Maria. I was just asking, I see your results showed from the urine diversion after 45 days, you say it's safe to handle for the pathogen breakdown. Is that 100% correct? Because as far as I know with your Ascaris, the roundworm, that doesn't break down so quickly. It takes a much longer time and it needs higher volumes. So we've done a decent study through that. So is it really still safe to handle?
Name?
Jacques Rast, sorry. South Africa.
Yeah, so those 45 days that we set up, that's for viruses and bacteria, not for Ascaris. We are running another experiment and evaluating real scale for Ascaris, and it takes a little bit longer. So we are trying just ash in a dry toilet to see actually if this 1 year that the WHO says it works with 1 year of storage, and we're running one experiment that it's now 2.5 years, and we do still have a lot of crazy happy Ascaris eggs in there. So, but for this other additives that we are testing, we are getting like 5 to 6 months.
Yeah, this is a follow-up question. My name is Mark Jesus from Duke University. Also for Maria, I wanted to ask you if you could comment on the choice of adding urea because of course it adds more nitrogen. And so depending on the end use, it might be a good thing, or if you're a nitrogen-rich zone, it might not be such a great thing. Also, you may end up with a lot of ammonia smell and nuisances. Can you talk about these things?
Sure. We add urea in the logic that we want to reuse it further, so we enrich it with nitrogen, so that's a positive aspect in our point of view. But we add, it's a little, it's a small amount. I mean, if we defecate about 200 grams, we put 1% of urea, 1 to 2%. So it's a small amount, but it's enough for what we want to accelerate an activation of pathogens. We have to stay, I mean, when the container is full, we have to keep it close, don't lose all this urea. And during the operation, while the toilet is functioning, we don't have like a big problem with ammonia smell. I think that because we have these big portions of ash and limestone, so we mixture limestone, ash, and this 1 or 2% of urea. So it's been working quite well.
Thank you.
We have one more question, and then we'll begin from the session.
Hello, I'm Vijender from AIT Thailand. My question is actually to Alison, Maria, and Soumya, all three of them. It's about the cost per unit on a single household basis as well as a community basis. And how does it financially compare to the existing cost?
I'm gonna talk with the Brazilian reality. So today to install like septic tank in Brazil, it costs like a good system with septic tank and post treatment. That is what we are looking for in Brazil for rural areas and all that. It costs for us, it's about $800. So that's a number that we get. And for this utility toilet, we are getting about $200 to $300 each one.
Okay.
The answer probably the same one. In India also, it costs around because the volume of the tank, if you have the money, you will make bigger tank like to obviate the erosion problem. In our case also it is around 200 to 250 per dollar per households of 5 to 7 people.
Yeah, I would really like to thank our presenters for this light session that they had. They presented posters and presentations. There's a lot more information, as you can see, that needs to be asked from them. I encourage you guys to go see them, visit them, speak to them, read the posters, find out more, because there's a lot of information. We're moving to the next session, and the moderator is Tina. Tina, Nova. It's still the same thing.